Right, this is the solution to the you try problem in the 1.5 notes, and we're asked to calculate the angle between the vectors -2, 5 and 3, -8 to the nearest degree. So to do this, we're going to combine our dot product formulas. So we know that u dot v is the magnitude of vector u times the magnitude of vector v times cosine of the angle between them. And I'm going to make a little sketch so that just we get an idea of what we're doing. So I'm going to call -2, 5 u and 3, -8 v. So -2, 5 would be something like this. Let's call this the vector u. And the vector v is 3, -8. So something like that. This is the vector v. We can see that we're going to get an obtuse angle. We should expect a negative dot product. So let's go through the steps. So let's figure out what u dot v is. We'll work on the left side first. And now we're going to use the formula in component form. So we have -2 dot 5, -2 comma 5 dot 3, -8. We're going to multiply the x components. So we have -2 times 3, and we're going to add that to the product of the y components. So 5 times -8, so it'll be -6 minus 40, which is -46. This is u dot v. Next, we're going to start computing the things from the right side of the equation. So let's find the magnitude of u. Okay, the magnitude of u, remember this is the vector -2, 5. So we're going to use Pythagorean theorem. It's going to be the square root of -2 squared plus 5 squared. So that's going to be the square root of 4 plus 25, which is rad 29. Next, let's find the magnitude of v. So the magnitude of v. So this v vector was 3, -8. So its magnitude is going to be the square root of 3 squared plus -8 squared, which is the square root of 9 plus 64, which is the square root of 73. We can't simplify these radicals, but even if we could, it wouldn't be helpful because we're just going to enter them into our calculator. And the calculator does not care if they're simplified. Next, we're going to put all of these things back into our original formula. So remember, we had u dot v is the magnitude of u times the magnitude of v times the cosine of the angle between them. And u dot v we found was -46. The magnitude of u was rad 29. And the magnitude of v is rad 73. And then we have cosine of theta. Next, we want to isolate cosine theta. So we're going to divide both sides of the equation by rad 29 and rad 73. So we're going to get that cosine of theta is equal to -46 over rad 29 times rad 73. And then theta is going to be cosine inverse of -46 over rad 29 times rad 73. You can put that into your calculator directly. I would use control divide to get the template. And if you punch all that in, you get 178.8 degrees as the angle between the vectors is 178.8 degrees.